Hello, I'm Yujie from the World Finals Stretching team. Here I'm going to explain problem Quartets, which is problem X from the 46 World Finals. So Quartets is a card game with 4 players. Here we number them from 1 to 4 and 32 cards. The cards are divided into 8 sets. Here we number them from 1 to 8 and each set has exactly 4 cards and we number them from A to D. So at the beginning of the game, each of the 4 players are given 8 cards. And during the game, there can have 2 actions. So the first action is one player I asks another player J for exactly a card. Here, in this example, say player I asks player J for card 3A. So in order for this to happen, player I must already have a card in set 3 in their hand. Otherwise, they cannot ask this question. So after they ask this question, 2 things could happen. Either player J has 3A or they don't. So if player J has 3A, then player J must give 3A to player I. And after that happens, player I keep asking questions. And note that player I does not need to ask questions to player J again. They can ask anyone. And another case is that if player J do not have card 3A, then they don't need to give player I anything. And then it's the player J's turn to ask questions. And also, player J can ask anyone. They don't have to ask player I. And the second action of the game is called Quartets. Say if a player has all the 4 cards in his hand in the same set, then they can just say Quartets and then throw these 4 cards away. Okay, that's the background of the game. So in this problem, you are given up to 1,000 actions in the game, and we want to know whether these actions can happen without cheating. So what is the earliest action that cannot happen without cheating? So what is cheating? Note that in the actions, we have 2 must. So there are 2 ways to cheat. The first way is that player I asks player J for a card, say 3A, but player I actually does not have any card in set 3 in their hand already. This is one cheat. And another cheat is that player J actually have this card 3A, but they claim that they don't have this 3A and do not give that to player I. That is also called cheating. So the question is asked about up to which, what is the earliest action that cannot happen without cheating? Okay, now let's go to the solution of this problem. So the solution of this problem contains 2 parts. The first part is about simulation. The second part is about matching. So for the simulation, we need to keep track of the states of the current game. So what is the state? The state is about the relationship between players and cards. We want to know for each card what's the relationship between that card and a player. So we need to keep track of, for each player I, whether this player must have card 1A, or they do not have card 1A, or we don't know their relationship. This is the first part of the state. The second part of the state is that we also need to keep track of whether each player I must have an additional card in a specific set. So this happens in this action. Say, if player I asks player J for a card, say 3A, but we know nothing about what is in player I's hand, then we know that after this action, regardless of whether this action succeeds, we know that player I must have a card of set 3 in their hand already after that, or otherwise they will cheat. So these are the states we want to keep track of. And note that the simulation part is highly non-trivial. Many things can go wrong. For example, if we already know that player I has card 1A, and then they ask for 1B, then they do not need to have an additional card in set 1, because we know that they have 1A. But if we don't know they have 1A, then they need to have an additional card. Also, if we know that player I has an additional card in 1A, and they ask for 1B, they get 1B, then this player I still must have an additional card in set 1, because that is before he asked, they must have that already. Okay, that is the simulation part. And then we go to the matching part. So after the simulation, we want to build a matching between all the cards and all the players. So we use the matching to determine whether this current state is valid or not. So in order to do that, first we remove all the known cards. Say if we know player I has card 1A, just throw that away. Oh, well, this step is not required, but good to do. And the second step is we want to build a flow graph to do the matching, and we want to prioritize the type 2 edges in the graph. Here is the type 2. So basically, we want to satisfy all these conditions, and these conditions can easily be represented by the edges in the graph, and this one we need something more. So how to prioritize the edges of type 2? So there are many things we can do. The first is we can prioritize them by using a flow with cost. we give them either very high or low cost to prioritize them, or we can build a flow graph with lower bounds so that these edges must be satisfied first, or we simply build a flow graph with special structures so that these edges are somehow satisfied first. All these things will work. Okay, that is about the matching part. And one final note of the problem is that this problem only asks you about a yes or no question. You do not need to get the exact state of the current game or the initial game, which means that you only need to prove that the matching exists. You don't need to get it, which means that the exact matching is not required, so that we only need to prove that the matching exists. So we can do that without doing a real matching. There is actually one judge's solution that uses the Hall theorem to prove that the cards and the players can be matched, and whether there is a valid matching or not can be proved by this Hall theorem. And with that, you can also solve this problem.